Welcome back. Today we're going to talk about Venn diagrams and set operations. A universal set, symbolized by a capital U, is a set that contains all the elements for any specified discussion. When a universal set is given, only the elements in the universal set may be considered when working the problem. A Venn diagram is a useful tool to show how sets are related. In a Venn diagram, a rectangle usually represents the universal set, capital U. The items inside the rectangle may be divided into subsets, which are usually represented by circles. Here are 4 different ways 2 sets may be represented in a Venn diagram. Let's look at the first square here. Again, we got a rectangle or a square. We got a capital U here. This represents the entire universe. Inside this universe, we see 2 subsets. We see set A and set B. In this example here, you can see everything that's in A is also in B. So we say A is a subset of B. If you look over here on the right, we got our universe and we got 2 sets A and B. These 2 sets A and B don't overlap. They don't have any elements in common. When this happens, we say the 2 sets A and B are disjoint. That's when they have no elements in common. If you look at this third one, both set A and set B are the same size. They're represented by the same circle. That means every element in A is also in B. Every element in B is also in A. So in this example, we can say set A is equal to set B. And then in our last example here, the fourth way 2 sets may be represented in a Venn diagram, we see set A and set B have some elements in common, but not every element in A is also in B. They have a few elements in common. When this occurs, we say the 2 sets, set A and set B, intersect. Okay, here's some more definitions. These are important. The complement of a set A, symbolized by A apostrophe. A lot of times I read this as not A. Is a set of all elements in the universal set that are not in set A. So everything in here is in A. And then everything outside of that circle A, we say that's not A. The A with a little apostrophe, that means not A. That's its complement. When 2 sets intersect, we use this symbol. It looks like a U upside down. Okay, so this is read A intersect B. That's a set that contains all the elements that are common to both set A and set B. So when you see this, you're looking for the elements that are in both set A and set B. So that would be this little area right here. A intersect B would be this little area. And then the last definition we have is union. And this is the one students usually struggle with. The union of set A and set B, symbolized by A union B, it's a set containing all the elements that are members of set A or of set B. So the union is all the elements that are in either A or B. So you list everything out in A and then you list everything out in B. Everything in that set has to be in either A or B. We associate the word or with union. With intersection, we associate the word and. It has to be in both of them. All right, let's look at this example here. Here's our universe. The universe that we are considering for this example are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have 2 sets in this universe. Actually, 3 sets, A, B, and C. C is the empty set, though, so it doesn't have any elements. Well, the first thing I want to do is I want to draw a Venn diagram that represents this universe. So I'm going to make a rectangle. This is going to represent my universe. And then within that rectangle, I'm going to put two circles, A and B. Now, I need to think about how these circles are going to look. Are these circles going to be disjoint? Are they going to be equal to each other? Are they going to intersect? Well, let's look at some of the elements in A. We got 1, 2, 3, and 8. In B, we got 1, 3, 6, 7, 9. So they do have some elements in common. So these two circles I'm going to draw in here are going to intersect. So I'm going to draw intersecting circles. Okay. So what do we have in A? We have 1, 2, 3, and 8. Well, 1 is also in B. So I'm going to write 1 inside here. 2 is, we'll call this one A. We'll call this circle over here B. Well, 2 is in just A. So it would be in this part of the circle. But then we got 3. Notice 3 is both in A and B. So I'm going to put 3 inside there. And then we got 8. What do we have in B? We got 1, which we already have. We got 3, which we already have. Then we got 6, 7, and 9. Now, these are not the only elements I need to consider. I need to consider all the elements in the entire universe. So, do we have 1 on our Venn diagram? Yes. Do we have 2? Yep. Do we have 3? Yes. Do I have 4? No. So I'm going to put 4 outside these two circles, because 4 is not contained in either A or B. All right. Do we have 5 shown in our Venn diagram? Nope. So let's just write 5 anywhere inside this rectangle, as long as it's not inside those two circles. 6 we already have, 7 we have, 8 we have, 9 we have, and then we got 10. So here's 10. And then this rectangle, again, is your entire universe. Okay, so it wants us to find these sets here. It says find the set of A union with B. So what you're going to do is going to look at your Venn diagram, or look at your sets up here. You can use both of them. Sometimes it's helpful to look at the Venn diagram. Sometimes it's helpful to look at it written in roster form. Well, this set has to have every element that is in A or B. Everything in this set will be in either A or B. So what I'm going to do is I'm going to list everything out in A. So I got 1, 2, 3, and 8. Now I'm going to list everything out in B. Well, we got 1. I already have that on my list, so I don't have to write it twice. 3, I already have that on my list. But B also has 6, 7, and 9. So this set right here is A union B. Everything in this set is an element of either A or B. Now, let's skip over this example. Let's skip this one. We'll come back to it. Let's look at this one. Notice by the A, you get this little symbol. You get A with an apostrophe. Whenever you see that, read that as not A. Okay? So, we want to do not A. I want to list everything out that's not in A. And we got to consider our entire universe. So if you look at the whole universe here, what's not in A? Well, in A we got 1, 2, 3, and 8. So what's not in A? Not in A, 4, 5, 6, 7, 9, and 10. So not A would be this set, the set that contains 4, 5, 6, 7, 9, and 10. Well, what do we want to do with not A? It says not A intersect with B. So intersection is what the two have in common. So what elements are in both not A and not B? Well, here's B, here's not A. What do they have in common? They got a 6 in common, they have a 7 in common, and a 9 in common. So the set that contains not A intersect with B would be this set. The set that contains 6, 7, and 9. Okay, let's go back to the one that we skipped over. We skipped over A intersect with C. So let's look at that. Let's look at A intersect with C. So here's A. Here's C. It's an intersection. So it's what the two sets have in common. So A intersects C. Well, in A we got 1, 2, 3, and 8. In C we got, it's the empty set. There isn't any elements. So what elements do they have in common? Nothing. The C doesn't have anything in it. So A intersect with C would be the empty set. All right, one last example. Let's do this last one. Notice this little mark is outside the parentheses. So what you got to find first is you got to figure out what is A intersect with B. Let's do that first. What's A intersect B? What elements are in both A and B? Well, look at your Venn diagram. What's in both A and B? 1 and 3. 1 and 3 is A intersect B. What does the symbol here mean? That means not those. So we want not the elements that are 1 and 3. So what are those elements? That would be all the other elements. So this set would be, it's not 1 and 3. So it would be everything but 1 and 3. So it would be 2, 4, 5, 6, 7, 8, 9, and 10. Questions? All right, let's look at some more examples here. Okay, we have this universe here. And in this universe, we got these random objects. We got a smiley face, we got a cone, a cat, Abraham Lincoln, a heart, 10, hexagon, 13, and so forth. In this example here, it says find each of the following using the Venn diagram. So I want to find the elements that are in set A. Well, what's in set A? We got a cone. We have the number 1. We also have this picture of a cat, and we have the hexagon. So A would be these elements here. And the next one, it wants us to find not B. So it wants us to list all the elements that are not in B. So we're going to list everything that's not in B. We see these elements right here are the ones that are in B. We want not those. So not those would be the smiley face, the cone, the 1, and the 13. So not B would be these elements here. Okay, now we got another union one. Again, the unions are going to be the one you're going to struggle with. A union B. The easiest way to do unions is if you have two sets, list everything out in your first set. So what is in A? Well, we already did A. It was the cone, it was the one, it was the cat, and the hexagon. Then you list everything out in B. And if you have elements that are in B that you already listed, don't list them out twice. So in B, we got the cat, which we already have, the hexagon. Then we got Abraham Lincoln. We got the 10. And we got the heart. So the set that contains A union B would be all of these elements here. Everything in this set is in either A or B. Everything in here is either in A or B. That's what union means. All right, I'm going to skip over a couple. I'm going to skip over these just to save some time. And this one. Let's try this one. A union with the empty set. Again, this is another way you can represent empty set. A circle with a slash through it. So A union empty set. Well, that's going to be everything in A. So again, we did A. So it'll be the cone, the one, the cat, and the hexagon. And then we would list everything out in the empty set. Well, what's in the empty set? Nothing. So we can't list nothing out. We can't list anything out if there's nothing in it. So this is our answer. Everything in this set here is either in A or the empty set. All right, let's look at the last one. It says B intersect with the empty set. So you got to look at B. Look at what's in B. Well, here's what's in B. Look at what's in the empty set. Well, here's the empty set. What elements do B and the empty set have in common? They have no elements in common. Because the empty set has no elements. So B intersect with the empty set would be just the empty set. That would be your answer. The answer would be this set, which is the empty set.